What if the future of energy storage wasn't about bigger batteries, but entirely new materials? Imagine a world where your phone charges in seconds, your car goes for thousands of miles on a single tank, and renewable energy is seamlessly integrated into every home. We're on the cusp of an energy revolution, and it's powered by materials you've never even heard of. What if the future of energy was not found in making batteries bigger, but in making them smarter? What if the very stuff inside them changed completely? Imagine your phone charging fully in the time it takes to tie your shoes. Picture an electric car so light and efficient it could travel from New York to Chicago on a single charge. Envision your home, powered entirely by the sun and wind, with a seamless supply of electricity day and night, rain or shine. These are not fantasies, they are tangible possibilities unlocked by a quiet revolution in materials science. The answer to our energy challenges may not be just more, but different. This revolution is not about tweaking existing lithium-ion technology. It is about fundamentally rethinking what a battery is and what it can be made of. Scientists and engineers are designing new materials at the atomic level. These are not just simple metals or chemicals mixed in a vat. They are intricate structures, like microscopic sponges or incredibly thin, strong sheets. Engineered solids, composites, and fibers designed to hold and release energy more efficiently, more safely, and in greater quantities than ever before, the building blocks for a new era of energy storage. For decades, we focused on packing more of the same material into a box. Now, the focus is shifting to creating entirely new materials with superior properties. Think of it like swapping heavy iron for lightweight carbon fiber in an airplane. The plane becomes more efficient not because its fuel tank is bigger, but because its body is better. In the same way, new energy materials make devices more powerful and sustainable from the ground up. This shift moves the conversation from the limitations of current chemistry to the boundless potential of new physics and material design. Instead of asking how much more lithium we can mine, we can ask what other elements and structures can perform the same job better. This opens a vast landscape of innovation, materials that are more abundant, less toxic, and easier to recycle. The quest is no longer just for a bigger battery. It is for a better, safer, and more sustainable way to power our world. And the journey begins with the very atoms we use. These innovations are the building blocks of the next era of energy storage, modular, scalable, and tuned from the material up. One of the most exciting new frontiers is fast-charging materials. The bottleneck is often the electrode, the interface where charge enters and leaves. Current materials like graphite can only absorb energy so quickly before they degrade or overheat. It's like filling a bucket through a narrow funnel. New materials act like a much wider funnel. Engineered nano-architectures create clear pathways for ions, the carriers of charge, to zip in and out with remarkable speed and minimal resistance. Graphene and specially treated metal oxides can form electrodes with enormous surface area and high conductivity, accepting massive bursts of electricity without damage. Plug in a nearly dead phone and see it reach 100% in 30 seconds. For fleets, vehicles could top up in minutes during short breaks, slashing downtime and eliminating sprawling overnight depots. For long-haul trucks, a 15-minute stop could add hundreds of miles of range. These architectures also reduce charging stress, enabling batteries that charge in seconds and endure tens of thousands of cycles with minimal capacity loss. Another transformative area: ultra-light, ultra-strong composites for vehicles. The heavier an object is, the more energy it takes to move it, a critical challenge for EVs. Much of a battery's energy hauls the battery and heavy frame itself. Make the car lighter, and every mile costs less energy. New materials offer strength without the weight penalty, strong as steel, at a fraction of the mass. Car body, chassis, and battery casing built from these materials drastically reduce mass. A lighter car can use a smaller battery for the same range, or push a standard pack past the 1,000-mile mark. Lightweighting boosts performance and safety, a more nimble vehicle that accelerates faster and stops shorter. Composites can absorb crash energy in a controlled way, protecting occupants inside a reinforced safety cell. Already in sports cars and aircraft, composites are scaling with new manufacturing, bringing lighter, smarter EVs to everyday roads. The dream of renewables faces intermittency. To rely on sun and wind, we need storage for when it matters most. Beyond lithium-ion, new materials promise safer, longer-lasting solutions tailored for stationary storage. Thermal storage heats salts or ceramic blocks by day, then converts that heat back to electricity at night. Safe, abundant, and durable for decades. Flow batteries store energy in liquid tanks, capacity scales with size. New, non-toxic, water-based electrolytes make them home-friendly. Smart controls let homes store cheap renewable energy and sell back during peaks, turning neighborhoods into resilient distributed power plants. The promise is immense, but safety comes first. New materials are tested for stability, non-flammability, and environmental impact, designed for ethical sourcing and full recyclability. Around the world, pilot projects prove the concepts, from solid-state breakthroughs to biocomposite vehicles and community-scale storage. Imagine phones that charge in an instant, cars that cross continents, and homes powered by endless sun and wind. Challenges remain: cost, manufacturing, regulation. But discovery is accelerating. The materials to build this future are coming sooner than you think.